So today's Digital Humanities colloquium is by Phillip Ströbel on innovating historical scholarship, the Bullinger Digital Project. Now, Phillip Ströbel is a postdoctoral researcher with a background in languages, both modern and ancient, as well as digital humanities. And his expertise lies in optical character recognition of historical documents, encompassing printed and handwritten text from the 18th century to contemporary newspapers, and also 16th century letters. Phillip is passionate about applying computational linguistics to preserve and analyze cultural heritage, and his educational journey includes a Master of Arts in multilingual text analysis and a PhD in computational linguistics, both from the University of Zurich. His presentation on the Bullinger Digital Project is testament to his commitment to advancing the field of digital humanities. So I'm very much looking forward to this presentation. I'll stop my share now, and then Phillip, you should be able to share your screen, and the virtual floor is yours.
Yeah, thanks, Menno, for this introduction, and thanks for having me here at your DH colloquium, and I'm happy to kick this off in 2024 with you with the talk about the Bullinger Digital project. So good morning from me to you, to everyone here that has joined so far. In the next 45 minutes, I'd like to tell you a little bit what we did in the project. But 45 minutes is never enough to explain everything. So if you have questions afterwards, please ask them. And should you have questions after we finish the colloquium, you can reach out to me via Twitter. And yes, I still call it Twitter, and I still use the bird, and I'm confident the bird will return sometimes. And there's also a Mastodon channel. You can reach out to me. And if you want to, feel free. I'm always happy to talk to people about the work we do here in Zurich. So what will you expect? So what will expect you in this talk? First of all, it will be shameless self-advertising, because during the last 2 to 3 years, we've published quite a few papers at conferences about the Bullinger project, about various aspects of the project. So the titles you see here are all related to this project, and it kind of shows nicely what you can do in this field. And I will also jump all over the place. So it's not dedicated to one specific topic. I will touch upon many things, and I will not be able to go into details very much, but we'll leave some room in the end to answer your questions, should you have any. And what I hope is to provoke some thoughts and also a fruitful discussion in the end. That's what I already said. But I actually want to start with our most recent contribution, which just appeared in the Journal of Open Humanities Data. And this is a special issue about multilingual workflows. And that's also what our paper is called here, our article, Multilingual Workflows in Bullinger Digital, Data Curation for Latin and Early New High German. So why do I want to use this? I'll tell you later, but first of all, what is the Bullinger Digital about anyway? So the person here in the center is Heinrich Bullinger. He was a Swiss reformer living in Zurich, a very influential person here in Zurich. And what is so remarkable about him is that during his lifetime, he was born in 1504 and died in 1574. So he had quite a long life. And during his lifetime, he received over 10,000 letters, and he wrote over 2,000 with people all over Europe, basically. And these are only the letters we know about. So these are only the letters that have been preserved. So there could be many more, but we have like a huge corpus of letters, over 12,000 in that sense. And we did quite some stuff with it, and this is what we did. This is the workflow in the project Bullinger Digital. And this is quite complicated, maybe at first sight, but I will walk you through all the different steps. We start with metadata processing, and we also go a little bit into the scanning of the letters and the handwritten text recognition down there. And I will also tell you something about code switching detection, normalization, named entity recognition, and also machine translation. And then in the end, I will also tell you what we're currently doing, because technically the first phase of the project is over. It ended in 2023, December, and now we started with phase 2.0, we call it. So, but first of all, the metadata processing. When we started the project, didn't have the metadata in electronic form. It was available to us as index cards in a huge catalog. And here you have an example of what this index cards look like. So you have all the metadata, like the date, who wrote the letter, who received it, and then some stuff people added by hand, like the call numbers here, and also the incipit, that is kind of the first sentence in the letter. There's much more information on there, but that's the most important things. And what we did is, first of all, we digitized these index cards and we applied OCR to it. And as you can imagine, the machine written text is kind of easily recognizable for a system, but the handwritings were a challenge. So what we did is we built a system to let people correct these index cards. So we have like the scan on the left-hand side and then a virtual copy of the index card on the right-hand side, and people were able on a website to enter their corrections. And we did this when COVID struck us, and within 6 months, all the 10,000 index cards were corrected by people who were interested in the project. So this was something very valuable for us, that other people contributed to the project. And what we did then with this metadata, we built a relational database, which served kind of as a starting point for all what was to come. So this was kind of a pre-processing phase for our project. So in the following, we wanted to add to this database. So what did we do then? There are already 20 published editions of the Bullinger letters. So since 1974, people took letter by letter, they looked at the original, went to the archive, transcribed it, and then they added some information that they thought was valuable, historical background, information concerning people that showed up in the letters. And during these 50 years, it is now, they added around 80,000 footnotes in those overall 20 editions. You see some of the books here. This is just a screenshot from the most recent publication. So this was the 20th edition, and just now they finished the 21st that will be published this year. So this is what you see here. And in 2016, the Institute for Swiss Reformation Studies here at the University of Zurich thought it would be helpful for researchers to search through these editions electronically. And that is why they built a web service where they digitized all these printed books. So they applied OCR to it, and they built a system where you could search through the PDFs, basically. There were no images of the original letters, just these editions. And what we did then with that, we took this ARPA PDF. ARPA was the company who was responsible for the digitization. And sometimes there were also native PDF files they used for the printing process, for the publishing process. And we extracted all the information, the text from it, and built our custom XML files for each letter to ingest it afterwards in the database I just mentioned. So this was one step that you see here. And the platform looked something like this. I don't know if the screenshot is too clear, but maybe you see it just fine. What you see here is the interface. So you see this is really a scan of a page from this book or from one of these books. And you can also look at it as an HTML, and then you see some meta information annotated in different colors. The problem here we had is that special characters like the e caudata, this is this sign here, which occurs frequently in Latin, or the U with a ring on top, which represents early New High German diphthong wo, is not represented in the data, which made us unhappy in that sense. And you see an example of this here, Schulmeister, this is the principal. Like this, it occurs in the scan, and in the text, this diphthong has vanished because the OCR they used was not ready for this, basically. And another challenge we face is that the first 7 editions were available as PDF only, and the rest in 2-step. This is the program they used to produce the editions. And it's really messy markup language in our for our taste, and it was kind of difficult to aggregate all the different formats. You see here we produced HTML from the PDF mostly to retain information about fonts and font sizes, because it gives you an indication about, is this a title, is this a date or something like that. Is this a summary? Here you see a summary, a very short summary of this letter. These were basically the main problem with the data we needed to work with. What we also had were about 5,000 provisional transcriptions. So these were transcriptions the Institute for Swiss Reformation Studies produced, but these were not edited text. And they sometimes did this in 2 steps, sometimes not. And this is why we sometimes have leftovers of this 2-step markup. And it was kind of difficult to extract all the text. So these leftovers would not occur. And what we did then is, with all the texts, so the OCR PDFs I just showed you transformed to an HTML file, and these 5,000 provisional transcriptions, we generated our custom XML file, which you see here, to ingest it into the database. And we put all the files on GitHub, which was very convenient, because like that everybody could edit the files and everybody saw what everybody does. So this is kind of a good thing if you collaboratively work on such data. So what you see here is, for example, that we did some sentence boundary detection, so we split up the letter into sentences. We also defined the language, so there was language recognition involved. I'll come to that later again. And what we also see is all the footnotes down there. There were these alphanumeric footnotes, letters A to Z, which were about what occurs in the letter. So if the writer underlined something or maybe added something between the lines, this would receive an alphanumeric footnote, and the numeric footnote is used if we want to add information at a certain place. For example, the first footnote here, we see that the name is mentioned somewhere here in the text, or maybe also in the metadata. And this footnote explains who this person was. So this was basically the stuff we did with the text basis. And at the same time, and now we already come to the scanning of the letters, at the same time, with our project start, so to speak, the Central Library of Zurich and the State Archive Zurich, where all the originals were, started to digitize the letters. They are collected most of the times in books. So what you need to do is actually, you have to take out the letters one by one. You have to open those books and in the end close them again. You might do some restoration if the paper is damaged. That's what you see here. And in the end, they scanned the letters and they provided us with all the scans. And I told you that there are 12,000 letters, more or less, that have been preserved. Each letter has at least each letter is at least 2 pages long, and the longest letter is 49 pages long. So we have not 24,000 images, but rather, I think it's around 40,000, and all in very high resolution quality. So the amount of data you juggle around is really huge. It's several hundred gigabytes. So that's a challenge as well. But that is the scanning of the letters. And what we then had to do, and you see this here, we have the original letters. We do some restoration, or the Central Library does it, or the State Archive does it. They scan it. And then we had to verify the scans because we noticed that the call numbers, an example of which you see here, were not always right. They changed over time, or they were not recognized correctly in our crowd correction phase of the index cards. Something like that could happen. And we had to make sure that the scan matches the call number. And this is why we built a scan app, we called it, where all the images that have been transferred to a IIIF server were available, and also all the metadata from the index card catalog that we digitized and corrected. And then we had to kind of match this information. And sometimes also scans were like in the wrong order. So we could correct the order here. And also when scans were like turned 90 degrees, we could say, well, turn this back 90 degrees to get the correct orientation of the image. So this is what we did with the scans. And then, of course, the scans were important for the handwritten text recognition. And this is, was basically my main contribution to the project. So we had the original letters, and we already had transcriptions, provisional transcriptions or transcriptions from the editions. And what we needed to do now is like align these transcriptions first. And what do I mean by that? You can imagine on one hand you have the image, and on the other hand you have the transcription. And now we need to know for each line in the image what text portion of the transcription corresponds to each line. Because the transcriptions were not line-based. This was another challenge. And for that, we used the text-to-image module. in Transcribus. And this allowed us to produce training data for the handwritten text recognition. And our project partners from Bern did then train models with Transcribus, which you might know. And here in Zurich, we used a transformer-based optical character recognition approach, so quite something different. And in the end, we compared what approach would work better. So, but back to the training data, with this alignment process, we could produce a training corpus of about 130,000 lines, which is quite big. The problem is that the distribution of authors is very skewed. Bullinger wrote to 800 different persons, or has received letters from 800 different persons. So there are 800 different hands in the training data. Most of them are from Bullinger himself, because we have 2,000 letters from him only. And then you see that there are some authors that have written to him quite often, and then others who have written to him maybe just once. And this is a challenge for the handwritten text recognition, of course. As you see here, because here we have the different handwriting styles from different authors. And what you might see as well, if you have some experience with dealing the data from this period, some of the data is in Latin, and then they use a humanist minuscule kind of writing style. And then there is data in early New High German, for which they use something we call Kurrentschrift, or I think the English translation is running script. I'm not sure about that. But you see different handwriting styles, even for the same author. So if, I don't know if I have an example here, I don't think so, but Bullinger's Latin writing looks very different from his early New High German writing, which makes it more difficult. But nevertheless, we trained some models. We had kind of a global test set of the overall data, which is 10% of the overall data. And then we wanted to check the performance on lines from so-called frequent writers who have written 10 or more letters to Bullinger. And we also wanted to compare this performance to data of infrequent writers. And this is kind of the results. What you see here are, on the one hand, this is the evaluation of the frequent writers and the infrequent writers. And there were different test sets, a multilingual test set in gray, a Latin test set in blue, and the early New High German test set in orange. And then there are different models. We trained the multilingual model, a model on Latin data only, and the model on early New High German data only. And the first thing you see is that, of course, all the models we trained perform better for the frequent writers than the infrequent writers in terms of character error rate. That is kind of the main measure we used. You can imagine 100 characters and a character error rate of 2% would mean that 2 of those 100 characters are wrong. So lower the score, the better for us. And the interesting thing is now that the data or the model trained on early New High German only performed worse. We have a lower score here than the multilingual model. So this is kind of a hint, or was a hint for us, that the more data, the better. And also maybe the model still learned something from the Latin handwriting styles when we applied it to the early New High German data. So this is more or less what I can say about handwritten text recognition. Well, I could say much more, but we'll leave it at that for the moment. Except I want to also mention how we integrated this in the interface, and this is what you see here. For the letters that received automatic transcription, we tell the users in the interface that it has been automatically generated. And what you also see is some kind of baseline that we extracted with the layout recognition. And then on the right-hand side, the transcription. And if we're able to read Latin, you notice that this is actually quite good. It has some problems with numbers, like this is not 30th of February here, but should be 21st, I would say. But overall, it gets the gist of what is written there. So now, as I said, in the beginning, I will jump around, and now we will do such a jump, and we'll tackle 3 problems in 1 slide, basically, because we did some more stuff in the interface. One of these things we did is language identification. And why did we do this? We noticed that in these letters, the authors switch quite often from Latin to early New High German and back. And usually when they talk about matters of the church, matters of faith, matters of the Reformation, they'll stick to Latin. And as soon as they switch to a more colloquial style, or maybe want to exchange gossip, something like that, they switch to early New High German, which is kind of interesting. And this is what we call code switching. And we therefore also did some work on code switching detection. And as you see here, we can tell the system to mark up the language. And then we see in this letter, for example, we have 51% of the text in early New High German and the rest of it in Latin. And it is not always as clear-cut as you see here. So here it is basically not so difficult to recognize the language switches, but it also happens that they start a sentence in Latin and then they switch to early New High German, or vice versa. So these cases are difficult to detect, but we managed to build a system that did it quite reliably in that sense. And this is also integrated into the XML files and therefore also the interface, which shows it like that. What we also did is named entity recognition, but not in the standard way, so to speak. So we didn't apply a model or anything like that. We only did this for the edited text. So for these letters that already have been published in one of those 20 editions. And what did we do there? We looked at the back of the book index, where all the named entities the editors thought it would worth to mention were listed together with the page they were listed on. And this is how we tried to match back the named entities to the letters. You see, for example, this is Osiander. There, either our system missed it, or maybe it is not in the back of the book index in that case. But other stuff like here, the Pope, I think that is, or another person called Stumpfen, they are marked here, and you have the possibility to hit the button where you can get a display of the persons. And the other thing we did also is the normalization of early New High German. And why did we do that? We want, well, early New High German is kind of difficult, even for German-speaking people. you might understand like 80%, but if you want to search for specific words, you might not know how they were written at that time. There was no standard spelling, so this is kind of difficult for search systems then, if you want to get to information. One example, for example, is here Kreuz, which is normalized to Kreuz, which means cross in English. And you might not know how this was written at the time. So you want to be able to search for the standardized German word. And this is why behind basically the early New High German text, we have this normalized version, which is not always correct. The text in red I marked here is kind of wrong. But still, it enables users to look for words in German and then nevertheless get texts back where this word occurs in early New High German. One example you have down there, which is kind of small, but maybe you can read it anyway. Here the search was for wine, which also is the same word in German, Wein. But in early New High German, it could have been written as in standard German, just with a small letter at the beginning. But it could also have been written with a Y instead of EI, or also just with I instead of EI. And with the standard German search word Wein, you would still find all of these occurrences, which is kind of handy. Another thing we did, and I'm jumping again, is machine translation. So this is the same letter you've seen before, but here we have a button called Übersetzen, so translate. And if you hit this button, you get transferred to our Latin to German translation system we built. And you see here that it only translates the Latin part and it ignores the early New High German part. Because you might very well understand this, but not the Latin part. And we did this pre-GPT time, so to speak. And at that time, we outperformed Google Translate and DeepL, but that changed after GPT launched, or OpenAI launched ChatGPT. And I will tell you something more about that later. But we also built this. We collected texts, Latin texts, which had a German translation, and then built a system which is still available, but might not be for much longer for the reasons I just mentioned and mention again later. Good. And the last thing I think I want to mention in our workflow is the TEI version of our corpus, which is very important because this is kind of the standard nowadays in the world of digital editions. There are rarely editions that structure their data differently. There's some graph-based approaches as well, which I like as well. And then they are easily transferable to TEI, which makes it nice, but TEI is kind of the standard. And this is why we have a transformation from our custom XML format to TEI. And this allows us to use the TEI publisher as well as to display the letters. And you see this kind of a bit different layout. Before we had, for example, facsimile on the left-hand side, transcription here. This is all customizable, but it is important to have this TEI version of our corpus to guarantee that our project lives on after the funding runs out, if you know what I mean. So this is very useful for us. And now at the moment, one side project within our phase 2.0 is to make the switch from our custom built system to the TI publisher. And we want to make it look as good as our version because we think our version is nicer. We've just started with that and are confident that we will make that work. And this brings me actually to the new avenues for digital editions. And this is where the innovation part, I think also from the title, comes in. And as a spoiler, it's all large language models, which are really hyped at the moment, not only at the moment, but for quite some time now, actually. And it's all basically GPT or ChatGPT. So as I already mentioned, translation, it is much better than the system we built. And we worked together with Latin specialists, and they basically said, yeah, well, now we're not needed anymore. GPT can do it better than we can. This is a bit exaggerated, but still, if you look at the translation that GPT provides, or ChatGPT provides in this case here, it was really a much better translation. Just to make an example, in the German translation, the author mentions that Osiander, another guy, has attacked the poem, so to speak, and this doesn't make sense. And in the translation provided by GPT, we learned that he was kind of provoked by the poem, and our system did not get that. Or the next sentence is nice as well, where it is, well, it is a German saying that the pot has a lid now, and in our translation, the pots are in plural, which doesn't make sense, and it is talking about the ceiling, which doesn't make sense either. And GPT translates it perfectly. So our aim is to integrate translations by GPT into our system because they are much better. Still, they can make errors, and they will make errors. And also for the early High German part, if we want to translate to standard German, there are errors, and we would have to take a closer look at why it produces these errors, and can we improve the system with some measures. What we also looked into is automatic summaries. So in the editions, every letter is preceded by a summary. At the beginning of the editions, the summaries are quite short, and as the edition evolved, summaries got longer and longer, and yeah, nowadays it's basically almost complete summaries, or in that sense also translations of the letter text. And what we did is we have the letter here, we have a human summary in German, and then we produce the summary in English, for example. And if we compare the German and the English summaries, we see that they are quite similar. It's not exactly the same. We could not expect that, but still, this works quite well. And this is also something we want to look at, look into, also as a service for the editors, because creating these summaries is quite a lot of work. And if we can speed up this process, we can maybe also speed up the publishing of the editions. Because as I told you before, in these 50 years, people have edited the Bullinger letters. They've managed to do 3,100 letters. If they continue like that, they will finish in 2150 or something like that. And maybe you want to finish a bit earlier. But actually, there are people who died in the process of producing this edition, which is maybe also natural, but we can nevertheless speed things up a little. What we also thought could be interesting is kind of visual storytelling. And this is now an example on the left-hand side of a pretty extensive summary of a letter in a newer edition. And you see, here is a 1, here's a 2, here's a 3, here is a 4. It kind of structures the contents of the letter and then summarizes certain aspects. So it's kind of, it has kind of a structuring aspect as well. And what I asked GPT to do here is to produce one image for each of these kind of paragraphs. And it always produced 2, but never mind. But it gives you an idea on GPT's imagination of the 16th century. And what was kind of funny is there is something mentioned about somebody preaching to the people, which is up here. And I don't think that in the 16th century there were microphones already. So this is kind of strange here. And also birds that look like planes sometimes. Or here the text, the letter speaks about some war is maybe too much, but I don't know the word for it right now, but some strategic planning. And this kind of looks like very 19th century, 20th century style. So it doesn't get everything right. But we thought it would be nice to kind of enrich the edition or our online system with visual representation or representations of what's actually happening in the text. And then for linguists, we also looked into a part of speech tagging with GPT because we wanted to find out if it performs better than other systems. And this is actually work that will appear in this year's workshop proceedings in the workshop on computational linguistics for cultural heritage, social sciences, and humanities and literature, which takes place in Malta in March. And we could show that traditional systems, and now we just look at Bullinger, produce worse 5% than fine-tuned, specifically fine-tuned GPT systems. And something that is now not GPT, but still in development, we also experiment with topic modeling because we want to assign basically categories to or keywords to each letter, and started with topic modeling. For the moment, this is really first results actually from yesterday. And yeah, I'm not too happy with that yet. We still need to do some tweaking. What is kind of interesting is that although there is early New High German data, there are only 3 topics or so which really are or contain early New High German words. And then if you visualize all the letters with 20 topics here, but all the letters, each point in here is 1 letter, and the most important topic displayed in this graph, basically. You see the language boundary, so to speak. So all the early New High German letters are here, and all the Latin letters are here, which is kind of interesting, but doesn't tell you too much about the contents. But if you look closer, you see that there are separations. For example, this red cloud down here are all letters where Luther is a topic. The green stuff here is all about the church, Satan occurs quite often in there. So this will kind of be some kind of religious thing. The brown cloud here is everything about Zurich and Bullinger. And yeah, this gives you a nice or an other perspective on the data, but we still have to do a lot of work in that respect. So basically what I wanted to conclude with is what would we do differently now, or what are the lessons learned if we started a project like this again. So first of all, we would start to work in TI XML from the beginning and also include the TI publisher as well. It is very important that you don't underestimate the pre-processing steps. It was very difficult to turn all the different input formats we had into one canonical XML file, so to speak. And different languages, if there are different languages in your data, it always makes things more difficult. Named entity recognition and linking is also challenging because there is variation in names, different spellings for the same person. And sometimes there are also duplicates in the case where the father has exactly the same name than the son. And what we also saw from the preliminary stuff we did with topic recognition, keyword assignment, whatever you want to call it, this is hard because topics overlap. It's kind of vague. Some topics are kind of vague sometimes, and we don't have too much data. So we have a lot for that period, so to speak. But more data is still mostly better data. And last but not least, if you want to use the data set, it is openly available. You can do with it whatever you want, as long as you cite one of our works, and then I think you're fine. But it's basically open to the public. And with that, I thank you all for your attention, and we can open the rounds for questions, as I wanted to indicate with Bullinger, according to GPT, who wants to ask a question. Thank you very much.
Wonderful, thank you. I think this was a really, really nice presentation showing the kind of the breadth of the project and some challenges you had. So that was really nice. I see there are a few questions in the chat. Tanya asks, have you compared your results on language identification and code switching on modern language pairs?
Can you repeat that, please?
So have you compared your results on language identification and code switching on modern language pairs?
Actually, no. We just had a system that could distinguish between Latin and early New High German, because these were kind of the main languages in our corpus. And then we applied some kind of heuristics where we had lexica also for early New High German and Latin, and then tried to identify the language for each word in a sentence. And with that, we wanted to kind of pinpoint the exact place where the change occurs. And then we marked this in the XML, but we just looked at early New High German and Latin.
So it's really like a specific system, so you didn't use it,
yeah,
kind of general language identification system.
No, we had to build it ourselves, because systems that are available, like LangID or the language identification system by FastText, they did not perform too well on Latin and early New High German. So this is why we built a system ourselves. Yeah.
Cool. So Tanya has another question. Is GPT so much better because it has much more data to learn from, you think?
It must be that, yeah. If you imagine that half of the internet basically is part of GPT's training data with really all the Latin in there, whereas we could only use data we downloaded ourselves, or we compiled ourselves, which is on a much smaller scale, much much weaker infrastructure, so to speak. We don't have the same infrastructure as OpenAI, of course. So I think these are the main factors that GPT's translation capabilities are so much better than our dedicated system.
Yeah, now I understand. I think Benson has a question that's actually kind of related to this. So have you done any experiments with BART or LLMs other than ChatGPT?
Not yet.
And what graph-based representations have you tried?
So the first question is about having used other systems than GPT. Not yet. I think BART just announced that they reached parity on some benchmarks with GPT, and we will definitely look into this because the downside of using GPT is that it is like a paid service. We have an account there, and we pay for every request we do on their API. So this is kind of the downside. So we will look into open source systems as well, for sure. And the second question is about graph-based models, or representations, but this is not in the context of GPT, right? I have to ask back here.
Benson, I don't know if you can provide some more information. Oh, okay. So as an alternative to TEI.
No, we haven't done that yet. But I've seen editions that use Neo4j, for example, to represent all their texts, and then it gets quite complicated actually, in that like every word is a node in your graph, and this is then like attached to the letter ID, and you have to find ways to represent sentences if you want to do that, languages, all of that. So it is possible. I can imagine that it also scales, but like still, as I said, I think TEI has established as a standard, or is establishing itself as a standard in the realm of digital editions. Not only that, but for sure in the realm of digital editions.
Okay, thanks. I see we're nearly running out of time, but there's at least one more question. Maka Bongwe says, thank you for the presentation. How would we be able to apply these techniques on languages with low resources like African languages?
Very good question. We're kind of dealing with low resource languages as well. I mean, Latin, yes, there are large corpora, but for example, for early High German, not so much. And I can imagine that the situation is worse for African languages still. But as to the question of how, I mean, it depends on what you want to do. I mean, if you have, I don't know much about the writing culture of African languages, but if you want to apply handwritten text recognition, OCR, then you have to go out there and collect data, and then the approaches we tried would work on this data as well. I mean, you just have to have enough data. But I think it's really about data collection and making the data available afterwards. I mean, you can think about the procedure OpenAI employed, what you want. Is it right to scrape all the internet to generate the training corpus and then train these large language models? What are the downsides and stuff like that? You can think about that what you want, but I mean, if you have like data, you have collected data and that is specifically about African languages, and it sits on your computer, then it would never get into those models. And maybe we have to start sharing all the data to also kind of raise the awareness that the African languages are out there and ready to be integrated into systems. But it's kind of clear that you always have to do more effort on your own if you work on low resource languages.
Yeah, thank you. So I found it quite interesting. I mean, you have quite a bit of data in a way, but you start with paper, you know, the originals.
Yeah.
Yeah. So the data is there, but it's not directly usable. So you will need to do the scanning and the correction, the transcription, etc. And of course, you can work on quite a bit of work that's already done in the past, but it doesn't mean that all your problems are solved. So I think in the South African setting, we're essentially in a similar situation. So we might have scans, for example, which might not be transcribed, spelling variation. So a lot of the problems that you described are quite similar to the South African context. So I think it is quite interesting to take a look at your work and see what we can learn from that. Okay, I see one more question. So I realize we're running a little bit over time. So I'm happy to continue a bit of a discussion, but I also realize that some people might need to leave. So I would really like to thank you, Phillip, for the presentation before all people leave.
Yeah, you're very welcome.
Cool. So Tanya has another question. Did you do the crowdsourcing via an established platform with payment?
No, it was without payment. People did that on their own. So, and it was a service we set up very quick and dirty, so to speak. It just had to be practical and not look nice. Yeah.
So I actually had a very similar question. So how did you then find the people, or how did you get this information to the people that will help you do the crowdsourcing?
We advertised it, of course. I mean, we advertised it over our channels we have at the university, but then also like magazines. Like there are some magazines that are concerned with the Reformation here in Switzerland, or certain church newsletters. Yeah, and this is how we advertised and asked people to participate.
Okay, and you had quite a few people that wanted to help.
Yeah, we had quite a few people, but it's always the same in those crowdsourcing approaches. There are very few people who do most of the work, and then very many people who do just a little bit of the work. But in the end, it needs everybody to reach the goal. And we did this in 6 months. For data that is not that interesting, we have to say. Correcting OCR mistakes is not that funny.
Yeah, no, exactly. Cool. No, that sounds really interesting. I think this is something we also need to keep in mind in the South African context. I'm not sure if there are any other questions. I don't see anything in the chat at the moment. If there are no more questions, unless people are frantically typing now, then I would really like to thank you for your presentation, Phillip.
You're very welcome.
I think it was a wonderful presentation. You kind of highlight the different problems with a lot of potential solutions, things that also that don't necessarily work. And I think a lot of the work you're presenting is actually very relevant to the South African languages, even though we're focusing on a completely different data set, of course. But thank you very much. I really enjoyed it, and I see more people thanking you for the presentation in the chat. So thank you.
Welcome. And as I said, if you have more questions, just reach out, and I'm happy to get in touch.
Okay, wonderful. Thanks. No.